High School and the Junior College. Welcome to the series of the lectures of intermediate first year chemistry. We have been discussing the different concepts of atomic structure from our previous classes. We have started with the basic subatomic particles, then we have discussed the different models such as Thomson model, Rutherford model and Bohr's model. Before Bohr's model we have seen the basic background of a Bohr's model, and the next we have started the postulates of a Bohr's model in our last session. Today let us discuss the pros and cons of the Bohr's atomic model, right. We have seen the defects of the Thomson and the Rutherford, and let us discuss the defects and the success of the Bohr's atomic model, right. There are different basics which are being taken by the Bohr. If we remember, the main postulates of Bohr's atomic model was, he tells that an atom is spherical in shape, and he also tells that the electron will be revolving around the nucleus in a particular path. As long as the electron is in the same path, its energy is constant, right. Whenever it jumps from its path, or else from the lower to higher energy or higher energy lower, it will be either released or absorbed, right. And we have seen that will be nothing but h nu, and we have seen the spectral lines of hydrogen, that is whenever it goes into the excited state, it has to come to the ground state, but it does not come directly. It can come to either the fifth orbit or fourth or third or second or first based on its energy, isn't it. Those line frequencies and that spectral lines, many scientists names are given such as Balmer, Paschen, like that, right. Then what are the main problems of these things, and are these all postulates correct? Now let us see how it became successful and a failure in some point of view. See here, what is the main success of Bohr's theory is that he tells about the stability of an atom, right. When an atom will be stable, isn't it? Is it right or not? Which means whenever he took the example of hydrogen atom, that whenever electron jumps from higher energy levels to the different energy levels, we can identify the stability, which means whether the atom is stable or not, isn't it? Which means we can easily clearly tell that a neutral atom is always a stable atom, right. If we give energy to that, the electrons will be jumping to the higher energy level, which is not stable, right. It will again come to the lower energy levels, isn't it? Similarly, he explained the formation of different lines in line spectrum in hydrogen atom, right. Once again I am telling, he explained only about hydrogen atom, right, which is always applicable to different ions such as He plus, Li plus 2 and Be plus 3, right. With this present theory which we have learned, helium plus, which means an electron is removed, which is again the size of hydrogen, right. Similarly, Li plus 2, Be plus 3, right, these are our single electron ions, isn't it, which means this hydrogen spectrum is applicable to ions such as He plus, lithium plus and beryllium plus 3, and he could also explain about the line spectrum of hydrogen atom by what he discussed about helium and lithium and beryllium plus 3 ions, right. And he also gave the formula of Rydberg's equation, that is he could explain about wave numbers, and his experimental values of velocities and everything were excellent, right. And he gave an experimental value of radius of an nth orbit, right. Till now there was no proper explanation of a size of an atom, right. If it is first orbit, for example let us assume hydrogen has only one electron, which is the first orbit, then he can directly write it as Rn is equal to 0.529 angstrom into n square by z, where z is atomic number and n is number of number of orbit in it, isn't it. For example, if it is first orbit, if an electron is in the first orbit and it is in neutral state, then I can directly write it as the radius of an hydrogen atom in neutral state is always 0.529 angstrom, that is the actual size of an hydrogen atom, right. There is the general formula of a radius of nth orbit. Is it clear? Once again let me tell, if an atom is in spherical in shape and, right, if this is the first orbit and there is the second orbit, this is the center of nucleus, then the distance between this center of nucleus to this orbit is given by r1 is equal to 0.529 angstrom into 1 square by z. If it is not hydrogen atom, if it is hydrogen atom, z is obviously 1. If this is 1 and this is 2, we can directly substitute the values in it. Is it clear? And he also explains the energy of an nth orbit, which is given by minus 13.6 into z square by n square into electron volt, right. Again, if it is hydrogen atom, this will be z will be equal to 1, that will become minus 13.6 by n square electron volts, right. These are the basic thing which Bohr can explain, right. Now, if we observe, he explained only the line spectrum, that is the spectrum which is in between, isn't it, which we discussed in the last class. That is, he explained only about a single electron atom, that is hydrogen. Will it be applicable to the multi electron atoms? Don't know, he could not explain it. And we solved, we saw that there is a basis, the whole theory is on the basis of electron magnetic wave theory, right. Could he explain about lines of electric and magnetic waves, right. What all we discussed in the last class was only the hydrogen spectrum, that is for different energy levels. He just tells that this is in different regions, right. Will it be in the particular electric and magnetic lines, isn't it? Yes or no, right. Therefore, we can tell the limitations such as he could not explain the spectra of multi electron species, right. Did he explain? He could not explain, right. He explained only about hydrogen atom, which is a single electron species, and he tells that it is applicable to these kind of ions. And the next thing is, he tells that, we can see that he cannot explain the fine structure, right. He is telling only about line structure. Line is when an electron jumps from higher to different levels. Did he explain about single electrons transition or at a particular frequency? No, he could not explain a particular fine structure of atomic spectra, and he could not explain the most important, that is Zeeman effect and the Stark effect, right. Zeeman effect is splitting of this line spectrum or the spectral lines in the magnetic field. Did he explain anywhere about the magnetic field and electric field, right. He assumes both are to be constant, right. He could not explain that, isn't it? Yes or no? Which means how the spectral lines behave in the presence of a magnetic field or in the presence of a electric field, that he could not explain about even in the hydrogen line spectrum, isn't it? One more thing is, he did not explain when an atom combines with another atom, right. Yes or no? He explained only about a single atom. Therefore, we can tell that he cannot explain the formation of chemical bond. And the last statement which he gives, that MVR is equal to NH by 2 pi. He could not explain properly about MVR equal, that is angular momentum is equal to integral multiple of h by 2 pi, right. He used the value of Planck's constant, but he could not explain why did he used as integral multiple of h by 2 pi. Actually, it is an experimental result, but he could not explain the main motive, which means what is the reason for it, right. And few more things such as he could not explain the position of an electron, right. He explained just that there is an orbit, but he could not explain to an extent that the position or the probability of finding an electron, right. And he could not explain the basic momentum, right. And he not only electric and magnetic field, he did not account for this dual nature of an electron or an particle, right. These are the few things which are mere limitations, but the main thing is whatever the model he explained, it was an actual basic of the atomic structure, right. He could explain the most basic things, that till then there was no person who could explain the radius of an energy, the size of an orbit, or he could not account for an energy of an orbit, right, energy of an electron or such particular things, right. If you see in the Thomson's model, he just explained as a complete closed thing. After that, when it comes to the Rutherford, he identified there are few particles. I mean, he could give the basic of the particles in it. When it comes to the Bohr's atomic model, he explained the actual size and the energy of an orbit, right. Based on this, there are few models developed such as a quantum models, isn't it? What are quantum? What is a quantization? We heard that, I mean, we discussed in the previous chapter, I mean previous session, that the energy whatever it is, when it jumps from higher to lower energy level, it releases energy, right. Not only that, Planck explains that the energy which is released or absorbed, it is always in the form of a quantized nature, that is no energy is released together, it releases in the form of packets, that is it released in the form of in the different numbers, nothing is released at one time. Is it clear? That particular basic thing is taken to develop a quantized models, right. Let us discuss this quantum models now. Now see here, on the defects and the success, on the basis of defects and success of the Bohr's atomic model, there are few theories being developed. The first theory, it is the dual behavior of a matter. What do this mean? We have been seeing this from the past many things, that few scientists tells that a particle can have different behaviors, that is it can have a particle nature and it can have a wave like nature. Then based on the properties of different models, de Broglie gave a kind of hypothesis that whatever matter is, the matter should always exhibit in both particle and wave like properties, right, which means whatever the particle it is. We have seen the few scientists such as Newton and the Huygens, they explained that the light particle whatever it is there, they explained it as a photon. A photon always travels as a particle, right, that is being given by Newton's corpuscular theory, whereas the Huygens, he tells that always the particle or the light wave, it passes in the form of a wave. Based on those both things, he explained a photon can be analogous to the electron, right, whatever the radiation, it consists of electron, isn't it, which means with the analogy of photon electron, he gives such an equation that E equal to mc square can also be equated as E equal to h nu, right. For an electron we know that E equal to h nu, right, that is for an electron we know that E equal to h nu, for a photon we know that E equal to mc square, Einstein's equation, where c is the velocity of a light. If we equate those both, we get mc square is equal to h nu, right, where nu is the frequency of radiation based on the relationship between frequency and velocity of light, that is c equal to nu lambda. I can substitute it and write it as nu is equal to c by lambda. C get cancelled, then I can get it as mc equal to h by lambda. What is the c here? C is nothing but a velocity of light. He assumed it to be velocity of an electron, then he wrote it as mv is equal to h by lambda. Is that right? Then he tells that lambda is equal to h by p, where this wavelength is always inversely proportional to the momentum, right. This is what he explained, that from the de Broglie hypothesis, he tells that whatever the particle, it should have a particle and wave like properties, right, which means that particle or wave, the wavelength of that wave like structure should be dependent on the momentum of that particular particle, isn't it, which means he gives the example, I mean based on that we can derive that there is some particle of this in the particle shape and it has a non-standing wave of a kind of structure of an electron. Is it clear? Which means it has a constructive interference, which means it will start at this particular point, it will join those both, right. For this kind of thing we get it as 2 pi r is equal to n lambda. What is this 2 pi r? That is nothing but this whole thing, right. Based on the wave particle we know that that is nothing but n times, that is fundamental frequency, I mean fundamental wavelength into integer, whether it is the first orbit or second orbit or whatever, right. Based on this, can we directly write the value of lambda here? What is lambda? H by mv, that is 2 pi r is equal to n into h by mv, right. Before that, see here, this is a kind of destructive interference, which means it is starting from somewhere and it is being passing through different areas, and it has again it is being in the destructive wave, that is there is a non-standing wave, this is a standing wave actually, right. A standing wave where the orbital, it starts from a particular point, again it reaches to that point, right. Similarly, here also the particle kind of nature is always similar to the wave like particle. In this case we can write like this, where lambda is h by mv. If we cross multiply and write this, can we get mvr is equal to nh by 2 pi, right. There is a statement given by Bohr, right. But one more thing is, he could not explain the actual meaning of this mvr equal to nh by 2 pi, right, which means de Broglie could explain the actual hypothesis behind the statement that the angular momentum is equal to integral multiple of h by 2 pi, isn't it? Now see here, the next theory, that is Heisenberg's uncertainty principle. There is also kind of a basic theory which is being derived or extracted from the failures or success of a Bohr's theory. See here, he tells that whatever the particle it is there, whether it is a wave or whatever, he tells that it is always impossible to determine the exact position and momentum of an electron simultaneously. It is actually a basic thing. If an electron is revolving around a particular orbit, I mean in a nucleus, which means if it is in the particular place, if we could able to find the position of it, we cannot measure the momentum of it. Is that clear? If it has a particular mass m, right, he always tells that the position and the momentum cannot be found out at a particular time, which means either this can be found out or this can be found out, right. That is why it is always greater than h by 4 pi, which is an impossible value, right. Then the momentum is m into vx of a particular electron at a position x, which means he tells that x and position and the velocity also cannot be determined, right, of a fixed mass, which means, is it clear? He tells about the position and the momentum cannot be measured simultaneously, right, of a electron or any subatomic particles, right. From this principle and the theory, we can find out the motion of a microscopic objects. Is it clear? That is the main significance of the uncertainty principle. Is it clear? He explains about the motion of a microscopic object, and this theory is not at all applicable to the macroscopic objects, right. And he ruled out fixed theories, such as there are many theories that there is a fixed path. Is it clear? There is not only in the Bohr's theory, there are few more scientists who tells that electrons revolves in the fixed path, right. It can have an orbit, but we can't assure that the electron always rotates in a fixed path. Then according to this, do we have any fixed path for an electron? No, we don't have. If we have, we can't find momentum, right. If we can measure the momentum, we can't define in which path is it traveling. Is it clear? From that statement, we can clearly tell that the whole path or the electron, whichever the path it rotates, we cannot define its path exactly, which means it is ruling the existence of a theories that describes of the definite path of an electron. Is it clear? From that, there are few more, from these basic things, there is one more model being developed, that is quantum mechanical model, which is actually the basic of the whole quantum mechanics. Is it clear? Which means based on this particular statement, he tells that an electron does not lie in an orbit, it lies in an orbital. What is an orbital, right? What is this quantum mechanical model, right? These are the basic things which had to be discussed about an atomic structure, right. What all we discussed, we have started from the subatomic particles, right, their existence, and then the different models such as Thomson, Rutherford and Bohr. What are the basic theories behind this models, such as Bohr's Planck's quantum theory, for Einstein, photoelectric effects, and we have seen this uncertainty principle, right. based on these things there are few more models explained, that is quantum mechanical model, which is actually the basic model of quantum mechanics, which is being explained by Schrodinger, right. Let us discuss these topics in our next class. Okay, this is for today. Let us meet in the next class about more interesting topics of atomic structure. Okay.